Did you know that 83% of organizations are now running containerized applications in production, but only a fraction have the experience to manage service meshes effectively? The skills gap creates a tremendous opportunity for you. Service meshes are transforming the way organizations manage, secure, and scale microservices, and Istio is leading this revolution. As cloud-native adoption grows, the demand for professionals skilled in service mesh technologies has never been higher. Top companies like Netflix, Airbnb, and Uber are investing heavily in service mesh technologies to manage their scalable architectures. If you're looking to validate your expertise and advance your career in cloud-native space, the Istio Certified Associate certification is what you want. This comprehensive training program is designed to prepare you for the ICA certification exam and to equip you with the real-world skills in deploying, securing, monitoring, and troubleshooting Istio. This course isn't theory heavy. Every module is packed with hands-on labs, real-world examples, and practice exercises where you'll apply what you've learned. And to make sure you're truly exam ready, we provide a mock exam modeled after the real ICA test to test your knowledge, refine your skills, and confidently take the final exam. Achieving your ICA certification validates your foundational knowledge of Istio architecture, traffic management, resilience strategies, and secure service-to-service communication, making you a standout candidate in today's cloud-native job market. Let's take a quick look at what you'll learn in this course. In the introduction section, you'll explore the fundamentals of a service mesh, the Sidecar Proxy model, and why Istio is essential for managing microservices at scale. Next, in the installation and configuration section, you'll learn how to install Istio using istioctl, Helm, and the Istio operator. All right, let's review the Istio Certified Associate exam and what this is going to involve. Now, the first thing you'll notice here is that this is obviously not free. You do have to pay $250 but that does include a free retake. I myself had to use a retake, and a lot of the people that I talked to who have completed this certification have also used the retake. And the reason is that this exam is quite challenging compared to other hands-on exams you might have taken. It is labeled as experience level intermediate, which is good because when I took it, it was labeled as beginner. I'm glad they adjusted this because it's anything but beginner. The passing grade can be found here in the ICA frequently asked questions. So if we open up this and we scroll all the way down, I believe right here, it is 75% or above in order to earn a pass. If you're familiar with any of the Kubernetes certifications, you'll know that this is a little bit higher. I think the Kubernetes certifications are 65 or 66% to pass. So it's already a jump of 10%. You do get the same amount as you do with the Kubernetes certifications, which is 2 full hours. And this is a proctored exam. And what this means is you are going to be doing this online. They review your desk, your surrounding area, make sure you're not cheating essentially, and then they will monitor everything you're doing. No whispering, you can't put your hands on your mouth, etc. So that's what the proctored exam is all about. And obviously this is a hands-on exam, so you will need to be very comfortable with Kubernetes, and you will need to be very comfortable using kubectl. And I do not recommend that you take this course or this certification if you're not familiar with Kubernetes at all. We have a lot of courses here at KodeKloud which can introduce you to Kubernetes, get you more familiar, and when you're done that, you can come back here and continue getting your Istio certification. You are going to be tested on the following domains here. So we have the Istio installation, upgrade, and configuration. This will include 1 or 2 questions. Traffic management is a big portion of the exam. This has roughly 10 questions, I want to say 3 that can be quite tricky. Moving on to resilience and fault injection. This has about 3 to 5. This circuit breakers question is quite tricky. The securing workload surprisingly had a lot more questions than I had thought. It has roughly 6 or 7 questions, and the advanced scenarios has 3 questions. 2 are quite tricky. So in total, there are about 25 hands-on questions. And what I mean by hands-on is you will need to use the terminal. They will ask you, do this and do that, and you are going to be doing this via the terminal using kubectl, applying things. That's why it's very important that you're familiar with Kubernetes and you're very comfortable using kubectl. So that's about 25 hands-on questions. And then at the very end, there are 5 multiple choice questions. They're mostly based on best practices and common issues. They're just 5 questions, but 5 easy points that you can get. And it's important that you manage your time well. In this course, we're going to follow the same structure as this domain. So in the next section, we're going to be installing Istio. Then we're going to move on to traffic management, looking at gateways, destination rules, virtual services, etc. We'll move on to resilience and fault injection, where we're going to be looking at fault injection, circuit breakers, securing workloads, authorization policies, and mutual TLS, etc. At the advanced scenarios, we're going to be looking at and some extras like common problems, best practices, and some tips and tricks to help you pass this certification. Some sections will include a hands-on terminal quiz. So not a multiple choice quiz, but a hands-on terminal quiz. And at the end, you will get a chance to take the final mock exam, which is going to be very similar to what you're going to be getting in the Istio Certified Associate exam. It's going to be 2 hours, and it will hopefully give you the best chances of passing this exam. Though I do have to mention that this is not, the final mock exam is not going to be identical to what you're going to be getting from the Linux Foundation. So just want to put that out there. This is going to be a mock exam. You're going to have 2 hours to finish it. And if you are successful, you should be able to pass it when the actual exam is presented. So without further ado, let's get started. In this video, we'll go over the requirements in order to pass the Istio Certified Associate. So all different types of engineers can benefit from using Istio, whether you're a DevOps engineer, a software developer, a SecOps engineer, or an SRE, it doesn't matter. Istio benefits all engineers in a positive way. Even though Linux Foundation's own website states no prerequisites, this is not true. Maybe what they mean is you don't need any prior requirements to take the exam, but you definitely need a few things before considering taking this course, and of course, the ICA certification itself. Now, knowing Kubernetes is essential and perhaps the most important requirement to consider. You should know what Kubernetes is, how it works, what a pod is, what a service is, especially what a service is. More importantly, you should know how to configure a lot of these resources you see here, like pods, deployments, replica sets, daemon sets, services, especially services. Istio revolves around services, so be very comfortable with that before you attempt to do the ICA. If you're quite new to Kubernetes, I suggest taking a Kubernetes course here in KodeKloud before continuing. Moonshed did a really good job with this Kubernetes for the absolute beginner. So I strongly recommend that you take this before considering the ICA. Now, I don't want to assume that everyone is familiar with kubectl or kubectl, but it's highly important. Most companies have adapted GitOps approach, so everyone's using something like Argo CD or Flux. But in the ICA exam, you will be required to apply, remove, edit, investigate, monitor, all from the CLI, and you will need to do this using the kubectl or kubectl. You might be asked to create a deployment or a service, so you have to do that in the imperative way. And if you're not sure what that means, it basically means you're using the kubectl CLI tool to create the resources as opposed to defining it in a file first and then applying it the way you would if you were doing a declarative way. Now, when you use the Istio, you're creating Istio resources, you are going to be creating it in a declarative way, but a question could be create a deployment in a service, and you want to know how to use kubectl and apply it in the imperative way. The Istio certification takes place inside of a Linux terminal, so it should be no surprise that one of the key requirements is that you're very comfortable using the Linux bash. So commands like cat, change directory, make directory, touch, curl, ping, etc. And you should probably know how to use a text editor like Vim. You can use Nano as well, but I think Vim is a better text editor. It's more powerful, flexible. Just definitely be familiar with one, as you will need to be creating files, etc. I did hear that you could use VS Code in the exam.
I don't recall this, but again, I like being in the terminal, and I'm pretty good at Vim, so I didn't take advantage of the VS Code. So it's probably best to just know a text editor anyway, because if it's not available, then you would at least have this backup. You should have knowledge of basic network concepts like how DNS works, ports, different protocols. That is highly important, especially HTTP, HTTPS, and TCP, as that is one of those key protocols that Istio will use in order to configure things. You should have, I guess, basic understanding of what Helm is and, how it works, and more importantly, how to apply Helm charts, as this might come up in the install upgrade configuration section of the exam. So you don't need to be a guru in Helm, but you definitely need to know what it is, how it works, and how to apply Helm charts. That could be one of the questions at the beginning, right? So it's not required, but I personally think that if you have any of these certifications, it will really go a long way. It's very beneficial because you get the experience of what the Istio Certificate Associate is going to be like. Even if you at least attempted it, but you didn't pass, I still think that gives you leverage over people who haven't even tried it. In order of easiest to most difficult, I think the CKA, the Certified Kubernetes Administrator, in that's just my personal experience, but just having one of these will be sufficient, I think. Again, not required. And if you're very, very familiar with Kubernetes, but you don't have any of these certifications, I strongly suggest that you at least attempt the mock exams that we offer here at KodeKloud in our Kubernetes courses before attempting the ICA, so you get a feel of what the experience is going to be like. Again, these are just suggestions, requirements that I will give you the best chances of passing. The exam is quite hard. So if you think you got these, there's no time to waste. Let's get started. Let's go over what a service mesh is. Imagine yourself back in elementary school, sitting on your desk, listening to the teacher. I know for me, it was hard to focus back when I was a kid. And naturally, all you really wanted to do was talk to your friends. Passing notes in class, if you're a millennial like myself, you'll definitely remember this. But for the newer generation, this is how you would communicate with your friends during class. Note that smartphones weren't really a thing until 2008, 2009. So the way that would happen is you would open the note, read it, and these notes would have information like a subject, the time, and who's involved. Now, passing two notes between two people is quite easy and straightforward, right? You know who the sender is, and you know who the receiver is, as the exchange is done between these two parties. Even between three people, as the middle person, you would simply forward the note to the receiver, right? Now imagine passing a note from the first row here, third student, to row 5, let's say student 3. Suddenly now you have to pass that note through multiple rows. It could be pretty difficult, right? So some of the issues, like how long will it take for that student to read that message? What if the message was lost or someone dropped it? What if a reply failed? What if a student isn't willing to cooperate in passing these notes? Also, how would you make sure no one else reads the private message before it gets to the intended receiver? What if a teacher catches you passing notes? These are all things, obviously, to consider. Now, if you think one big classroom was difficult, what about passing a note from one classroom to another? What about passing notes inside of a university campus from one academic building to another? The solution? A service mesh. A service mesh is like a classroom assistant that will organize, secure, and track the notes being passed around the class. It ensures that the communication goes through smoothly without issues. If student A, for example, wants to send a note to student C, student A needs to pass that to the assistant who will ensure the note gets to student B. And now, again, because this assistant is the one handling it, no one else is going to read that message. It's going to make sure it gets to that student. And you can extend the same concept across multiple classes. Each class has an assistant. And for example, if student A wants to send a note to student X in another academic building, let's say arts, class 405, The student sends it to the assistant, and the assistant will exchange those notes on behalf of the students. Now, the role of the service mesh here. Well, first of all, it ensures that communication stays private between the two parties. The service mesh makes sure that notes don't get lost and are delivered accordingly. A service mesh logs everything. Notes coming in, notes going out, it logs everything. And it also handles issues that arise. Maybe a student is absent or something. In summary, a service mesh addresses all of the issues you see right here and allows students to send notes freely without having to think about the method of sending it. And I think that's really the most important part of a service mesh. Students can simply focus on writing the notes, and the service mesh, in this case the assistant, will handle the rest. There are many service options. We have, of course, Istio and my personal favorite, but you also have other options like Linkerd, which is very, very popular. You have Cilium, another great tool that actually doesn't use sidecars at all. Traffic is another good tool. HashiCorp's console is also another option. And I believe AWS has one called AppMesh. Nginx Plus offers a service mesh as well. Istio definitely stands out as the service mesh most used around the world, followed by Linkerd. I don't have solid evidence or any report that I can show you, but I'm confident to say that Istio is used a lot more than Linkerd is. It just offers more features, etc. If you have a look at this service mesh report for 2025, it is estimated that the service mesh market size will grow to $7.1 billion by 2033. So less than 10 years, this will grow quite a lot. And learning a service mesh is going to be essential. It's going to be crucial. It'll be a requirement eventually. And getting Istio certified will just get you more noticed. Anyway, no time to waste. Let's get started. Before we learn what Istio is, we need to understand what a sidecar is. Can you remember learning how to ride a bike? You'd get on, try to keep balance, but you would fall. Sidecars were very popular in the 1950s, but you can see how balance is not an issue anymore. Another person can sit inside and help with balance while keeping you company on your ride. The person inside the sidecar can help with some tasks like watching for traffic, checking for merging cars, navigation, so you can focus on driving without being distracted. The person in the sidecar can also communicate with others on your behalf. So, what is the role of the sidecar? In summary, it helps take the load off by handling extra tasks, organizing, navigating, and communicating with others on your behalf. That is the main role of a sidecar. So when it comes to proxies designed for traffic management inside of a service mesh, you have a lot of options. You have Envoy Proxy, of course, which is used by Istio, though Istio does use an extended version of Envoy Proxy. HashiCorp's console also uses Envoy Proxy. Kuma, which is another service mesh, uses Envoy Proxy. And I believe AWS AppMesh also makes use of the Envoy Proxy. You also have another proxy by the name of Linkerd 2 proxy, which is used by Linkerd, of course. You have the traffic proxy, which is used by the traffic mesh, of course. And you also have one called HA proxy, which can be used with, I believe, HashiCorp's console. You can change to use HA proxy instead of Envoy. You can use HA proxy with other maybe built in-house service meshes that also make use of this HA proxy, but Envoy Proxy is the most widely used sidecar proxy in the context of service meshes. Envoy Proxy is an open source, high performance service proxy, and it's what Istio uses as its sidecar. It works very similar to software load balancers like Nginx, if you ever used it. Originally created by Lyft, the project has been adopted by the Cloud Native Computing Foundation. I should also mention that the word or the term proxy and sidecar are quite often used interchangeably. So you might hear me say proxy, or you might hear me say sidecar or someone else, and just know that they're talking about the same thing. Another term is also sidecar injection, which refers to adding the proxy to the workload that be Envoy proxy, a linker proxy, or HA proxy. So sidecar injection means injecting that sidecar into the workload. So how does it work? Think of Envoy proxy as a traffic controller for your application. In a large system where there are many applications that need to talk to each other, Envoy proxy makes sure that the messages between those services get to the right place in the fastest and safest way possible. If you recall the classroom example, right? The assistant here is the Envoy proxy. It takes your note and makes sure it goes to the right student. In a Kubernetes ecosystem, the Envoy proxy is a completely separate container that runs alongside your main application workload and acts as the middleman, intercepting all communication in and out of the application. Just like the sidecar, the application drives, and the sidecar is that proxy that will intercept the communication in and out and do all those tasks for you. Now, the Envoy proxy will route traffic, choosing the best path to take to deliver the message. It also acts as a load balancer, distributing traffic across multiple instances of a service. Envoy proxy also makes sure that the communication between services is secure. Envoy proxy encrypts the message so that no one can snoop in on it. And it also ensures that only trusted services can talk to one another. So Envoy proxy also helps you monitor to see what's happening in your system. It can track how much traffic is going to each application, how long it takes to get a response, and if any applications are having issues. So why use Envoy proxy? Well, simplify communication. Envoy proxy makes sure that all applications can communicate with one another without worrying about complex network problems. Security, right? It ensures that all the data being transferred between services is encrypted and secure. Performance, Envoy proxy helps track the health and performance of your applications. Reliability, another big one. Why use it, right? Envoy proxy ensures that even if one server goes down, your application keeps running by redirecting traffic to healthy services. And some advanced options, right? Envoy proxy offers things like rate limiting, circuit breaking, compression, traffic mirroring capabilities, etc. You can install Envoy proxy on any Linux distribution, basically. You can install it on Mac OS X and even directly on a Kubernetes cluster using something like Helm. However, managing individual proxies across a complex Kubernetes cluster environment can be quite challenging. Just think about managing each Envoy proxy for each workload individually. It could be a nightmare. Luckily, there is a better way, and that is called Istio. Let's talk about it. Now that we know what a sidecar is, we need to understand what Istio is. So Istio is an open source service mesh that helps organizations run distributed microservice-based apps anywhere. But what does that really mean, right? As you probably already know, there are many types of container runtimes. There is Docker, of course. We have Containerd, Rocket, Podman, CRIO. There's also LXC, Mirantis, etc. Managing these container runtimes can be challenging and time-consuming. Luckily, there is a solution, and that solution is called Kubernetes. Kubernetes is essentially an orchestrator that can manage different types of containers. It takes care of creating them, destroying them, restarting them, etc. So, Istio is to Envoy proxy what Kubernetes is to containers. Istio is an orchestrator that facilitates the management of these Envoy proxies. Pretty straightforward. The architecture. An Istio service mesh has two components, the data plane and the control plane. Now, the data plane is responsible for managing and controlling the actual traffic between microservices. The data plane deploys sidecar proxies, in this case, Envoy proxies, alongside each workload and handles routing, load balancing, encryption using mTLS, and security authentication. Now, the control plane is responsible for managing and configuring the data plane. It handles distributing policies, certificate, managing service discovery, authentication, authorization, and dynamically updating configurations for all of the proxy sidecars. All of this is handled by Istio, which is a pod or the pilot container that runs inside the cluster when you install Istio. Istio that provides service discovery and configuration. It translates high-level routing rules that govern traffic behavior into Envoy proxy-specific configuration and applies them to the sidecars at runtime. Istio also acts as a certificate authority and generates certificates to allow secure mTLS communication between the workloads. Istio also allows you to secure service-to-service and end-user authentication with built-in identity and credential management. Additionally, you can essentially use Istio's authorization feature to control who has access to your services. So why use Istio? Well, traffic management is number one, right? Istio enables you to customize traffic routing based on different criteria. You can do traffic splitting, canary releases, etc. You can do mirroring. Without something like Istio, you would go back to using an application load balancer to distribute traffic, but you would lack that fine-grained control that Istio offers. Security, a huge one, right? Istio automatically encrypts traffic between workloads using mTLS. If you think about without something like a Istio service mesh, you would send unencrypted traffic between workloads, right? So if you're okay with that, and if you're not, you have some compliance issues, I guess that's not a big deal, but a lot of companies have compliances now. So Istio allows you to send encrypted traffic, but without it, you would be sending unencrypted traffic between workloads. You would be managing TLS certs, right? If you did need to encrypt traffic and or develop some custom encryption implementation that nobody really wants to do. Authentication, right? Istio allows you to implement access control policies and configure to only accept traffic from authorized services. We have, of course, observability. Istio provides centralized logging, makes it easier to aggregate and analyze logs. You can use tools like Jagger or Datadog APM to trace, debug, and optimize microservices. Resilience, reliability. So Istio allows you to implement resilience strategies like circuit breaking, timeouts, retries, mitigation of cascading failures during a service degradation, for example. Without something like Istio, you'd have to build, a combination of practices where devs are implementing circuit breakers, timeouts within the workloads to prevent these cascading failures, and it's a lot of work. And I think one of the best reasons to use Istio is that reduced operation overhead. So Istio reduces the manual operation burden of managing proxies, encrypting traffic, building extended logging, traffic routing, etc. Developers no longer need to code all of these things into the application because Istio will handle all of that. And actually, that's the best part about Istio. It's that it's transparent to the developers. In fact, the workload or the application doesn't even know the sidecar proxy is there. And I think that's really cool. So I should also mention that Istio has a sidecarless mode called Ambient Mesh, and it's a lot faster and more lightweight. Ambient Mesh splits the sidecar functionality into two components, a Z-tunnel and a waypoint proxy. The Z-tunnel is a Rust-based agent deployed as a daemon across all the nodes, and it handles, mTLS, authentication, authorization, and logging for pod traffic in the node. And waypoint is an Envoy proxy deployed. It's deployed as a pod, not as a container. It's a standalone workload, not a sidecar proxy like the standard service mesh. And it is deployed per namespace or service account. The main benefits of using Istio Ambient Mesh versus traditional Istio Service Mesh is obviously the reduced number of proxies to manage and slashing costs by reducing the computing memory requirements per node. However, I should mention that the Ambient Mesh is not in the Istio Certificate Associate. So we're not going to dive into it, and we're going to stick to what the certification exam is about. But I thought I would just let you guys know that Istio does offer this sidecarless mode if you wanted to dig further into that. And that wraps up this first introduction section. Let's quickly summarize everything we covered in the next video. I'll see you there.
All right, let's review what we learned in this introduction section. We reviewed the ICA. Remember, it's an intermediate exam, hands-on, 2-hour long, with a passing grade of 75% or above. Yes, it's about 10% higher than a regular Kubernetes certificate. There are certain prerequisites that are recommended in order to take this course and the ICA certification. Knowing Kubernetes is essential, so remember that. A service mesh facilitates the communication between workloads. It ensures security and reliability. Sidecars or proxies, whatever you want to call them, they're containers that run alongside the application and proxy all traffic going in and out. Sidecars reduce that manual overhead, managing proxies, building extended logging, traffic routing, etc. Developers can focus on the application and they don't need to code authentication, encryption, fault tolerance into the application because the sidecars will handle all of that. Istio uses Envoy proxy as the middleman, along with HashiCorp's console. Kuma uses it as well. It's definitely the most widely used proxy being used in a Kubernetes ecosystem today. There are many options in terms of a service mesh, but Istio definitely is the most popular, like I said, and the most widely used today. Remember this last part of if you ever confuse what Istio is. Istio is what Kubernetes is to containers, an orchestrator that manages these Envoy proxies for us. And with that, we come to a complete of this section. I'll see you guys in the next section.
Let's dive into what we'll cover in this module. So we're going to go over the requirements before we install Istio. And spoiler, you do need a Kubernetes environment. I hope you know that. We'll install the Istio CTL and learn how to enable it after installation. Next, we'll review Istio's profiles, options. Also, an alternative way to installing Istio is using Helm, so we'll go over that. We'll learn how to customize Istio using the Istio operator. This is really, really important. 100% this is going to be on the exam. And we'll finish off by updating and uninstalling Istio. No time to waste. Let's get started. All right. In order to install Istio, you need a running Kubernetes cluster. You can use Amazon EKS, GKE, the Google's, or even Azure's AKS. If you want to do a local environment, you can use either Kind or Minikube, but you do need a running Kubernetes cluster. There are two options when it comes to installing Istio. You can use the Istio CTL, which is the Istio CLI tool, or you can use Helm. We will review both ways as you will be asked to install Istio, and it could be using either option. I'm going to go with the Istio CTL, but it's worth, knowing how to install Istio with Helm, because if you're using it in production, you probably want to use Helm. You're not going to be using Istio CTL to install that. Now, before installing Istio, you need to download Istio CTL. Essentially, we will be using Istio 1.18.2 as that is what the ICI exam environment will be. It is quite behind. The latest I think is 1.25.2, I think. So it's quite behind, but that's what is based on the exam. And it has changed a little bit, but not crazy amount of new things. So we're going to stick with 1.18 because that's what the exam is on. You can find all of Istio's releases in GitHub. You can just head to GitHub Istio and find all of the releases. But in page 8, you can find the version that we're going to need, which is 1.18. And that's the one that we have to install. You can virtually use any Linux distribution. You can use the curl command, pass in the version of Istio CTL you want to install. And once Istio is installed, you can essentially change into the directory or the downloaded folder. And using the export, you include the path environment variable, and you can confirm that Istio CTL is running. You can see here that it says no pods in the Istio system, and that's because we installed, or this diagram right here, the screenshot, you installed Istio CTL, but you haven't installed Istio itself on a cluster. So don't get confused. Istio CTL version is just checking the version, and it's just telling us that it's that 1.18.2. You also need to install kubectl, kubectl, whatever you want to call. You need this installed in your environment, and this is how you would install it, depending whether you're on a 64-bit or ARM 64. I suspect that a lot of people already have this installed. It will be available on our labs. So you don't have to worry about it, but I just thought it's worth noting. If you want to install both IstioCTL and kubectl in your own OS X terminal, you can use Brew. If you're not familiar with Brew, it's really just a package manager for OS X. Keep in mind that the version of Istio we're going to use is 1.18.2. So if you do end up going with Brew on your Mac OS X, make sure that you download and install the version we're going to be working on. But in our labs, like I said, they'll all be 1.18.2. Now, once we have the kubectl and IstioCTL on our terminal, we can have a look at Istio's profiles. Istio does include a few profiles here, as you can see. And here's just a quick overview of the profiles. On the left here, you can see the core components. And on the right side, you can see all of the profiles. There might be one or two missing here, but you have the default profile, which doesn't include the egress gateway for some reason. The demo that includes all but the ambient mesh stuff. That's CNI and Z-tunnel. That's the ambient mesh mode, which we're not going to be talking about or going over. So the demo is the profile we're most likely use. You have that minimal that only has the Istio D component, the control plane. You have remote and empty. And then you have this preview profile that it seems to be the same as the default. And of course, you have the ambient profile, which uses no sidecar. So it's a sidecarless mode. To install Istio, using IstioCTL, we can run the IstioCTL install. We set a profile, we pass the -y for yes. It should take a few minutes, and then you can confirm by checking the pods in the Istio system namespace. And you can see right here that we have the egress and the ingress gateway, as well as the Istio D. That tells me that Istio is installed. It's important to note that nothing happens if you install Istio other than a few resources. Like none of your applications will be impacted. And that's because Istio is installed, but it's not enabled. And if you want to use Istio, you need to enable it. Assuming you already have, the workloads, for example, like in the screenshot, in your Kubernetes cluster, you can inspect them. We know that Istio will inject a sidecar, but these deployments that you see right here, these pods, all read one of one, meaning that there's only one container running in these pods, which means that there is no Istio sidecar proxy injected in them. To enable Istio, we can label the namespace. And after labeling it, so you can see right here, we're just labeling it Istio-injection equals enabled. After enabling it, you can confirm that the label is there and check. Now, once you see that injection enabled right there, you can check if your workloads in that namespace have Istio sidecar. Now, if you see this one of one right here, you don't have to worry about it. You can just delete or recreate it. But the labeling of the namespace works great because it allows you to control where you want to use Istio. If you just install Istio and it would enable across everything, that means that every namespace would have a sidecar injected. And you'd be consuming a lot more resources. So the fact that you have to enable a namespace to use it is, I think it's a genius way of controlling those resources. Like I said, you can spend all the time, restarting the deployments, or you can just delete. For example, this book info right here application, we can recreate it again. We can check the pods, and now you can see this 2 of 2, which means that the Istio sidecar proxy is injected. You can easily inspect the pod to see what containers it has and verify that one of the running containers inside the pod is the Istio proxy along with the app pod. In this case, you can see the details container, and then you can see the Istio proxy, and there's the image right here that Istio proxy is using. Let's say that you don't want to, enable a whole namespace for Istio injection. You just want to inject particular workloads. So you can do a manual sidecar injection. Now you do need to have a manifest YAML file in the system. So let's just say you pull down that book info using wget, that book info.yaml file. And then using IstioCTL, you can kube inject and add the Istio sidecar proxy to the deployment without labeling the whole namespace. This is definitely going to be in the exam. We will look more into this later on, but just FYI, this is how you would do a manual sidecar injection. And you can just get your pods, and you can see that they will have this 2 of 2. Now, if you're using Helm, you need to install 3 components. So first you pull down the Istio the chart, and you need to, like I said, 3 components. You need the Istio base, And this chart includes the cluster-wide resources like service accounts, cluster roles, binding, etc., all that jazz. You have the Istio D chart, and this is the control plane, essentially the brain of Istio, very, very important. And finally, you need the Istio ingress. And this chart is used to deploy the ingress and egress gateways to the cluster. Once the components are installed, you can pretty much use Istio in the same manner as we discussed using Istio CTL. Istio CTL does have a few options, really important ones, two in particular that I can think of right now. So you can use Istio CTL to validate an Istio YAML file, which is important so you don't apply files that have syntax errors, for example. So you can see right here that I can use Istio validate and then the name of the file, and it tells me if it's valid. If there's any errors here, it will tell me that it can't, it doesn't know what XYZ means, or for example. So really, really important. We are going to use that. You can verify the installation, though note that this does take quite a long time. And I don't think it's going to be in the certification exam, but if they do ask in a multiple choice question, for example, Istio verify install, we'll go through the whole installation. It takes over 20, 30 minutes. And possibly the most important command that will be super, super useful is the Istio CTL analyze command. This -a is for all namespaces, for example, and it allows you to see all of the, if there's any errors really. And we're going to be using this throughout the course, and I advise that you always use it, especially in the ICA exam. There's one way of just analyzing that one namespace. This is probably the one that you want to use during the exam. Whenever you write an Istio configuration file, any resources for Istio, you run the Istio CTL analyze -n and the name of the namespace, and it will pick up any errors if there's any. And it's always good to know that you made a syntax error or something. But enough talk. Let's head to a terminal and start practicing, because after all, the ICA is hands-on. I'll see you there. Now, before we can start using Istio, we need to download it. Now, first thing I want to check is if Kubernetes is running and if any workloads are in here. So kubectl get pods -a. Yep, it's running there. Let's do kubectl. I guess there's nothing in the default namespace. Nope. Now, I want to install something in here, so I'm going to use one of Istio's example workloads, and it's this book info application. Now, if you are not familiar with Kubernetes, I strongly recommend that you first take one of our Kubernetes courses here at KodeKloud. You can get caught up, learn about Kubernetes before you continue on. But if you are familiar with Kubernetes, then you might have seen this sample book info application. Now, the workload itself is not really important. What is important here is that it is running. So let's do kubectl get pods. And if we do that, there you go. It's still creating it, but I'm convinced that this is going to work here in a few seconds. So the next thing we want to do is download. While this is creating it, let's download Istio. So I'm going to copy another command here, and I am downloading Istio 1.18.2 because the exam is based on this version. So it's best that we install the version that we're going to be tested on. So I'm going to go ahead and download that. And I'm going to run the get pods again. Yep, they're all running there. Now you can see right here. One thing that we want to check is let's describe one of these pods so you can understand what's going to happen once Istio is installed and it starts injecting the sidecars. Let's do kubectl describe pod details. And if you scroll up here, you will see the containers component, and you'll see there's only one container running in this pod. There's the details, there's the image, the port that this is running on, etc. Now, what's going to happen is when we install Istio, we should see another container in here that contains the Istio proxy. So let me clear this out of the way. Now, the first thing we need to do is install Istio. We downloaded it and we have it in here. So we are going to go into Istio here, .2, and we are going to add the export. So we're going to do export path equals, and there's a variable pwd. If you don't know what that is, this is print working directory. We're going to put this to bin, and we're going to pass it into our path. Now, if we do which Istio CTL, you'll see that it's in there. And if we do Istio CTL version, you should get this. And this is basically saying the version you're using 1.18.2, but there is no Istio pods in the Istio system namespace. And it makes sense because we haven't actually installed it. So now I want to do Istio CTL install, and we're going to set the profile to demo. And I'm going to do a -y. Now I know that in the presentation, we showed the default profile, and you could do that if you're running your own Kubernetes cluster. But inside of our labs, because the default profile is a little heavy when it comes to resources, we are going to use the demo. I'm going to go ahead and install this, and it's going to install the core components, which is Istio base, Istio-D, and then it is the demo profile. So it's going to install both gateways, the ingress and the egress gateways. And once this is set up, you can see right here, ingress and gateway here. Let me go ahead and clear this out of the way. Let's do kubectl get pods, and let's check the Istio system namespace. And you can see here that we have our 3 pods, Istio-D, which is our core, our control plane. And then we have the ingress and the egress gateways. So that's set all and done. Let's do kubectl get pods again for that workload. And you can see that there's 1 of 1. So now how do we actually inject the sidecar proxy? Well, that's easy. We need to label a namespace in here. So one of the things that we can also check with Istio is to verify if Istio is running in a particular namespace. So we can do Istio CTL analyze and then pass in the name of the namespace. And you'll see right here that this will tell you right away. It says the namespace is not enabled for Istio injection, and it actually kindly gives you the exact command you have to run. So we'll do kubectl label namespace, and I'm just going to copy all of this right here, and I'm going to paste it. And now if I rerun the analyze again, we should see, and it says, hey, don't worry about these warnings for now. That's okay. Basically, what this is saying right here is that the proxy is not mounted in there. And the reason it's not mounted is because we created the workload before Istio was installed and before we labeled the namespace. So a quick way to do this, it's let's delete and reapply this. You could restart the workloads, but I'm going to delete and then I'm going to recreate. So let's do a command actually here. Let's do kubectl get ns, so namespaces, and let's do show labels. And you can see right here that the only namespace that is labeled is the default one. Nothing else has this Istio injection enabled, right? So I'm going to go ahead and clear this out of the way. Let's get pods again. And this is still terminating, but now we can, let's do a watch on this until it's done. Oh, and it's just finished. So now what we could do is reapply the workload. I'm going to reapply the workload. Yep, it's created. I'm going to clear this out of the way, and let's do get pods. And you can see right now that instead of 1 of 1, which is this is the number of containers in the pod, now we get 2 of 2. So now let's inspect one of these. Let's do kubectl get pods. Let's do kubectl describe pod details. And if we scroll up here, you'll see that there's a lot more information than there was before. You see all these environment variables. They weren't there before. And if we scroll up right here under the containers, you'll see the details container. And now we have the Istio proxy container. And this is passing a lot of information. Don't worry about that for now. But we have installed Istio. So let me clear this out of the way. Let's do kubectl get pods. And you can see that they all have this sidecar proxy mounted. Now, this was automatic injection. Now, let's have a look at how we can manually inject the Envoy proxy. Now, the first thing I want to do is maybe create a new namespace. So let's do kubectl create, let's one call db, right? So now if we do get ns and show labels, you'll see that db doesn't have the injection enabled. So any workload that we create here will not have the Istio sidecar and proxy injection. So let me create a pod really quickly here. So let's do kubectl run, and we'll call this Redis no proxy. And we're going to use we're going to pass it in the DB namespace. And let me use the image Redis. And let's do that. So now let's do kubectl get pods in the DB namespace. And it's creating it. It's okay. It's going to work. And it worked right there. And this is called the no proxy. Now, what I want to do now is create the same namespace, but the way that we did it right here, this is an imperative mode, it's called. If you're familiar with imperative and declarative, this is the imperative. We need to create a declarative way. So what I'm going to do is rerun this again. Now I'm going to name this just Redis. And I am going to do the try run equals client. I'm going to spit it out as a YAML. That looks good there for me right now. And I'm going to write this to a file called pod.yaml. Clear this out of the way. And now we have our pod.yaml in here. So what we can do now is we can inject it manually on creation. So let's do Istio CTL kube inject. We're going to pass in the name of the file, which is the pod, and then we're going to pipe it to kubectl apply-f-. And what this is going to do is going to create that Redis pod, but now it's going to inject the sidecar. So let's do the get pods for the DB now. And you can see the difference between the Redis no proxy and the Redis with the proxy. If we inspect this, CTL describe DB and just Redis, DB, describe pod, excuse me, you'll see right here that we have both of our containers in here. So now we have our Redis container and we have our Istio container. And that sums it up for installing Istio using the Istio CTL with a profile. But in the next presentation, we're going to be talking about Helm and how we can install Istio and all of its charts using Helm. I'll see you guys there. Now, using Helm to install Istio is very easy. First thing we need to do is add the repo for Istio. I'm just going to copy and paste here so I don't take too long. We're doing Helm repo adding, and we're going to name this Istio, and there's a URL. We then need to do Helm repo update. This will pull the latest versions for this specific repo, though we are going to use this particular version. And then we can do Helm repo list. And there you go, it is in there. So the first thing we need to do is add the Helm Istio base. And we're going to do Helm install Istio-base. That's just the name that we want to, it doesn't really matter what you want to name it here, but makes sense to call it Istio-base. And this is where the chart is actually placed. It's in Istio/base. We're going to pass in the namespace, create it. We're going to do the version 1.18.2. And I'm going to set the profile to demo. I'm going to go ahead and press enter. The Istio's CRDs or custom resource definitions. So this will have the services, the cluster roles, etc. So once that is done, now we need to install Istio-D, which is the control plane. Now I'm going to be passing in a few variables here. If you are using your own Kubernetes cluster and you have plenty of resources, this will do. So we're doing Helm install. We're going to call it Istio-D because it's Istio-D. It's under Istio and it's called Istio-D. We're going to pass in the namespace, Istio, which we already created in the last one, Istio system, the specific version 1.18.2. Again, that's the one that we're being tested on. And we're going to set the profile. You can press enter and that will work. In our labs, this will not work because by default, it's going to try to use a lot more memory and CPU than is available. So what I'm going to do is I'm going to set a few parameters in here. And don't worry if this doesn't make sense to you. We already talked about it, but we are going to have a look at it in the terminal in the next demo and in the next lab. But this is basically when you're using the Istio operator, you can set specific parameters in here. And what we're doing here is we're setting the Istio pilot to only request 128 meg for memory and to only use, I guess, 250 M of a CPU, which would be a quarter of a CPU, I guess. So I'm going to go ahead and press enter there. And I'm going to clear this. Let's do kubectl get pod and Istio system. And it's still creating it. And there it is. It's running now. And now the last thing I need to do is install the last chart, which is the gateway chart. So I'm going to go ahead and copy that. And we're just going to do Helm install Istio ingress is the Istio/gateway. This is going to be in a new namespace called Istio ingress. We actually might need to do dash namespace here. Let's do namespace, Istio ingress. It's going to create it. I'm going to press enter. And now let's see if we get any pods in this kubectl get pods -n. And there you go. We have our Istio ingress. Remember, this profile we didn't pass in to create the egress gateway. This will do for now. Now let's go ahead and install the Redis application. So let's do kubectl run Redis. We're going to do image equals Redis. And let's clear this, do kubectl get pods. And you'll see that it's 0 of 1 because this does not have Istio enabled. So what we need to do is we just install Istio. Now, if you recall on the last lab and the last demo, we do have to label our namespace. So let me go ahead and copy that command. And we are going to label the default namespace with the Istio injection enabled. I'm going to go ahead and label that. Let's do kubectl get pods again. You'll see that it is running. Let's get rid of this container and let's recreate it again. kubectl delete pod Redis. Okay. And it's going to delete that. Let's do get pods again. And then let's clear that. And now let's do run again. And let's do Redis get pods again. And it's initializing. And then now we have our proxy in here. Let's do describe pod Redis. And you see right here that we have 2 containers now under the containers. We have the Redis and we have the Istio proxy. Let's do Helm list all. And you can see that we have our 3 charts here. We have our base, again, our CRDs, our custom resource definitions, very important. We need the Istio-D, which is the control plane, the heart of it. And then we have our Istio ingress chart in here. So that about covers it for installing Istio using Helm. I'll see you guys in the next one where we'll be installing Istio using the Istio operator. Now, we already talked about the Istio profiles, but here you go. You can see them quickly. We're going to stick to demo for our labs. Now, one of the things that you could do with istio.ctl is you can print out all of the YAML content to a file or simply to output, I guess. You type istio.ctl profile dump and then the name of the profile you want, and you can output it as a YAML, or you can use a JSON output too as well. And what it'll do is it'll print it out. This, for example, here, it'll print it out. Now, this is just a little snippet. There's dozens of lines of code in here, but you can essentially see what that profile has. Now, we already looked at installing Istio through istio.ctl using a Helm. Now, installing Istio using the Istio operator gives you much more flexibility to adjust, remove, add any additional components and configurations, for example. The easiest way to do this is to dump the output, as we just saw, to a file, and then install Istio using that file. Now in here, there's really no difference in this command because all you did was you dumped out the default profile to a default.yaml file. You made no changes and then you installed it. So here you could have just done istio.ctl install --set equals profile default, and it would have done the same thing. But if you wanted to make changes to it, you can then edit this file. Now in the ICA, you will most likely be asked to make adjustments to Istio using the Istio operator. For example, they might ask you to, install Istio and enable egress gateway, which means you need to change this from false to true. Or they might ask you to give it a different name than Istio egress gateway, for example. They might ask you to make CPU or memory adjustments and either limits or requests. So you would need to adjust this in that file, save it, and then install Istio. This is the benefit of using the Istio operator. You have a lot of flexibility, and in the exam there is at least 1 or 2 questions based on the Istio operator, so it's important that you know how to make these changes. If you're not sure where certain options are, you can easily visit Istio's documentation, the Istio operator spec, for example, and have a look there at the operator options. You have really 3 options here, or 3 main sections. You have the global sections that allows you to configure the profile name, as you can see there right under the spec, the namespace, revision, etc. Then you have the mesh config, and that section includes the configuration of the control plane components like proxy config, selectors, logging, and then you have the components themselves. This section allows you to enable or disable individual components like enabling egress gateway or adjusting CPU memory limits, requests for proxies like we saw on the last slide. This component section is where the settings for the Kubernetes resources mostly lie. So you can go and have a look at that. You can also customize the Istio installation using Helm. And the easiest way is to use Helm show values for a certain chart, for example, Istio D in this case. And you can inspect the options, make changes, and then install the Helm chart using the -F for the file option to use those values. You can do the same thing for the Istio D and the same thing for the Istio gateway. You are dumping the values into a file, making changes to that file, and then using that file for the values to install one of those charts. To update the installation, you can modify the existing Istio operator file you already applied before if you did have one. For example, enable the egress gateway and set enabled to true and reapply it using the istioctl upgrade -F and then the name of the file. And that can easily make changes to your Istio installation using the Istio operator. You can also do that with Helm. You can use the Helm upgrade command to update any changes to the chart. Now to uninstall Istio, it's very easy. All you need to do is run istioctl uninstall, and you can pass in the name of the profile, and you pass in the actually there's a typo here. It should be --purge. Or you can use the Helm uninstall, and you would need to uninstall it for each chart, unfortunately. But enough of the theory. Let's quickly go over to a demo, and I'll give you guys an opportunity to do this on the lab. I'll see you there. So we installed Istio using istioctl. We installed Istio using Helm, and now we're going to start looking at the how to install Istio using the Istio operator, perhaps the most important method when it comes to the exam. You can be sure that there's going to be at least one question around installing Istio with the Istio operator. So you can see here that we have our book info application. We already have istioctl here. So let's do istioctl version and no Istio because there's no pods because Istio hasn't been installed. So I'm going to clear this out of the way here. And now we want to do is dumping the profile to see what we can have a look at in order to configure our Istio operator. So istioctl, we're going to do profile, we're going to dump. You can do the default again if you're using your own Kubernetes cluster, but in our labs, you need to stick with demo because the default profile uses a lot more resources. So we're going to do demo. I'm going to do this, spit this out to YAML. You can see here that it spits out a bunch of stuff, but I want to spit this out in a file. So I'm going to write this to demo.yaml. And now we can have a look at it. We're just going to install it. And you can see that there's the core components, right? And the things that it's going to be enabled, the things that are not going to be enabled, a bunch of things right here. Don't worry about that for now. What we're going to do here is just install it. So we're going to do istioctl install -f demo, and we're going to do -y. And this is going to install the demo profile. Basically the same thing that we did with the istioctl install command when we were passing the profile. Now we're actually passing the YAML file, the manifest file, but essentially it's going to be the exact same installation as we did with the istioctl. Helm was a little bit different, but this is going to be exactly the same. Now let's have a look at kubectl get pods, and let's do istio system. And we have our istio egress and our ingress and our istio D. So that's working as expected. We can go ahead and start labeling manifest. So let's do istioctl analyze -n for default. It's saying, hey, this is not done. This is hasn't been labeled. So I'm just going to copy and paste here. Doing that, let me do kubectl get pods. And this is not, we have to delete it and recreate it. But before that, now we need to start making changes to it. So one of the things that I don't like, this is just an example, in the gateway Pods is that there's no space between egress or dash gateway. Like I would like it to say Istio egress dash gateway and Istio dash ingress dash gateway. Just my preference, but it could be a lot of other things. We're going to also have a look at the resources that this is using. So let's inspect this one pod. So let's do kubectl describe pod in the Istio system namespace. And if we have a look right here, we go up a little bit more, we'll see that there's some limits in here. So the limit is 2 gigs and the request is 10. I think the limits are way too high. Let's change that so that we can maybe use it a little bit lower. I'm going to clear this out of the way. I'm going to open up the yet demo file. And in order for us to rename the default gateways, you can see right here that this is the egress gateway and this is the ingress gateway. The first thing we need to do is actually disable this one. It's kind of redundant, but we're going to do false. And now what we're going to do is I'm going to add, I guess, 1, 2, 3, 4, 5, 6, 7 lines. So I'm going to do 7, yank, and I'm going to do here, and I'm going to enable this one. So I'm going to do true. And then here, I'm going to add that dash gateway. Now, you could name it whatever you want. This is just an example. And the other thing that we said we were going to do is we were going to add limits. So I'm going to copy 1, 2, 3 here. So let's do 3, yank, and change this to limits. And let's do that. The max is 40 and the max memory that this can ask is 80. Just to keep it just for that. So I'm going to go ahead and then now I'm going to copy all of this. And I am going to paste it here. And now I'm going to make this true, and I'm going to put the dash in here. So we're going to do dash, and we're going to add the same limits. So we already had the limits right here. Let's do right here. So let's do 3, yank. This is the false one, and this is the enable one. So let's do here. And let's change the request to be 20 and 40. And then the same thing with this one right here, the enable one. So we'll do 20 CPU and 40. So it's double everything. So the limits is 40 and 80 for memory. And then the requests are going to be 20 and 40. And I'm going to go ahead and save that. And now instead of applying it again, we can do Istio CTL. We can validate the file. So this is a good idea to validate the demo file to see if there's any errors. Yep, it says valid, so I'm good with that. Istio CTL upgrade. Now I'm going to do dash F and pass in the demo YAML file. And I forgot to press the dash Y. And this is going to hopefully remove our old gateways and install the gateways again, but with custom names and with some custom resources. So let's see what happens when this is finished. I'm going to pause my video for 1 second. Actually, no need. It looks like it already did its thing. So see, you can see that it's removing things. That's good. That's always a good sign. So now I can do kubectl get pods and Istio system. And you can see here that now we have that dash. I mean, I'm just picky about that, but you could not have that bother you, whatever the case. More importantly, let's inspect the resources. So I'm going to clear this out of the way, get the pods again, and now let's do kubectl describe pod in the Istio system, and let's the Istio ingress. And if we scroll all the way up, we shall see that the limits have been set. Now, this is, I don't want to give you false hope, but something like this, it's going to be in the exam. So I suggest that you're very comfortable using it. So the other thing I want to show you, and perhaps one of the things I haven't mentioned yet, and I probably forgot, so I apologize, is that the exam is open book. So you're going to be able to get to the documentation. You're not going to be able to use Google or anything like that, but you can get to this documentation. This is the Istio operator options. So you could see it's really important that you go over this. You could see right here the gateway spec. So this is the gateway, for example, what we were just touching right now. We enabled it. We can pass in a namespace. So we can, the exam question might actually be something like, let me see right here. It might be like, hey, create the egress gateway in a particular namespace. So you would pass in a namespace below that. And in this documentation, you could see right here, the namespace is one of the things that you can pass. And then the other thing that I want to show you, this is going to be in the documentation, so don't worry about it. Let's go into the customizing the installation configuration. I strongly recommend that you go through this at least once. And you can see right here a few of the options that they are going to customize right here. So there's the resources. The question might be, hey, make sure that the pilot resources has certain CPU in memory or the horizontal pod autoscaler. And if you demo this and do pilot right here, you can see right here that these are the requests right here. So it really depends on what the question is going to ask, but be familiar with how to dump the profile into a file, and then how you can add whatever it is that the question is asking you, whether that's adding changing the ingress and the egress, or disabling one or enabling one, or creating one, or adding resources on the pilot, etc. It's very important that you come here and you have a look. At the very minimum, you should know how to get to this page exactly. So you would documentation, sidecar mode, more guides, customizing the installation configuration, so that if you don't remember on that one spot, you're not having to waste time here typing how to do something. You'll hit you right away and say, oh, I know exactly where that is. You'll come down right here, you'll review a few of these examples right here, and you'll have an understanding or a good idea of what you need to do. So again, very, very important that you know how to install Istio using the Istio operator, because I can almost guarantee that that's going to be in the exam. And that's it for this section. Thanks, guys. Grab a cup of coffee, and I'll see you guys in the next section. So we reviewed the prerequisites of installing Istio. Remember, you need a Kubernetes environment. They can be a kind, EKS, Minikube, GKS, whatever. You can install Istio using two methods, but Istio CTL is the recommended method. Remember that installing Istio doesn't do anything other than use resources. You will need to label the namespace in order to inject workloads with Istio Sidecar, or you can do that manually. You definitely need to know this for the ICA exam. Istio CTL profile dump command allows you to output all the configuration, and it's very useful, especially for the Istio operator questions. You can use Helm to install Istio, but you need to install all three charts, the base, the Istio-D, and the ingress separately. The Istio operator is very, very important, and it's almost guaranteed you'll get a question on this. So make sure you have a look at the operator options that we discussed in the customized Istio installation presentation. And finally, you can easily update a configuration by changing the option in the file and reapplying it, either using Istio CTL or Helm.
If you're interested in mastering Istio and leveling up your cloud native skills, check out our comprehensive Istio Certified Associate course on KodeKloud. We offer hands-on labs, real-world examples, and everything you need to pass the ICA exam. Click the link below and get started today.